And so this is the last page for today, which is April the 16th. Now, hopefully, you have this either completed, mostly completed, or now you're just checking your answers. It really has no benefit to you to be able, or to, there's crumbs, just copy the answers. Now, when I did this first one, I was like, oh, this is easy, I'll just fill it in. But it says, examine the diagrams below. Each is a step in the Punnett square method. Put the steps in order by writing the numbers 1 to 4 below them on the correct blank. So it's pretty much 1 through 1, 2, 3, 4. What do you think the answers are? So you always start off with a blank Punnett square, so that one should have been the easiest one. That's number 1. Okay. Number 2, you need to put the parents. Okay, so this is one parent, this is the other parent. These are their alleles, so this would be number 2. Okay. Third one is, now they do their Punnett squares a little bit differently. They put the first letter down. Now, I always just combine mine, but that's just how I do it. So if it's easier for you to start off by putting the first letter first, it really doesn't matter to me. But this is going to be the third step. You have 50% of it done. And then this would be the fourth step. Okay, pretty easy. That one's pretty straightforward. What do the letters outside the Punnett square stand for? So these letters here. That one's pretty easy. The genotypes of each parent. And again, it's not like one parent goes always on top, the other parent's always on the side. It really doesn't matter. The genotypes of each parent, so their alleles. So if someone says, what is an allele? You're just talking about the letters. You're talking about this is the specific traits. Let's say this is the trait for hair color. Okay, that's what the allele is going to be for. So they're showing the genotypes of each parent. Now in this case, they're both heterozygous. But nonetheless, this could be for hair color. So the alleles just represent one trait. Okay, cover this up as I go. What do the letters inside each square stand for? So what do the, of course, God, this thing just has a mind of annoying me. What do the letters inside each square stand for? Those letters represent, so they represent the possible genotypes, that's E, genotypes of offspring. So it's just a probability square, pretty much. We're just talking a little bit about math, but for the most part, I always enjoy Punnett squares. I always think they're kind of fun. Represents the possible genotypes of the offspring. So there's 4 offspring in this case. Now there's ones that you can have 2 different characteristics for, and those are just a pain in the butt to do. But for right now, we are simply looking at, they represent the possible genotypes of the offspring. Now, it says examine the following Punnett squares and circle those that are correct. So I think only 3 overall are going to be corrected or correct on here. So it's kind of up to you to figure it out. So looking at this first one here, I have big D, big D. Well, I know right off the bat, just looking at the very first Punnett square, this one is wrong. It should be 2 big D's. Okay. Even if I was to continue on, this should be a big D, little d, big D, little d. So that one's correct, and that one's correct. But these top 2 ones are wrong. Looking at this one, so we have 2 homozygous parents. So homozygous dominant up here, homozygous recessive over here. Big D, little d. Big D, oh, that one's wrong. Okay, this should be a little d. Let's just double check, see if anything else is wrong. Big D, little d. Big D, little d. No, so that one's wrong. Looking at this one, so we have 2 heterozygous parents, so big D, okay, that one's good. Big D, little d, good. Big D, little d, good. And remember, the lowercase letter never goes first. What's next? Oh, we have little d, little, no, that one's wrong. So that one should have been a little d, so we know that Punnett square is incorrect. Okay, let's look at this one. We have 1 homozygous dominant, crossed with a heterozygous. So we have big D, okay, that one checks out. Big D, checks out. Big D, little d, checks out. Big D, little d, checks out. That one I know is correct. All right, so on that top row, there's only one that is correct. Okay, I'm looking down a little bit more. Okay, let's scroll back over here. Just move the paper back over there. I should make it a bite of my oatmeal. So I want my dehydrated apple cinnamon oatmeal. So, I probably could have paused at this point, but at this point, I'm too far down or far into my oatmeal to really shop. So, looking at this one, here's my big A, big A. This Punnett square checks out, or that little section of it. Big A, little a, that one checks out. Big A, little a, checks out, and 2 little a's. I know this one is correct. I probably shouldn't get my lines on there. Right? 2 heterozygous parents. Big A, big A. And again, I kind of go different orders of which way I want to go. Sometimes I go down first, sometimes I go over. Just really doesn't matter. But big A, little a, that one checks out. Big A, little a. No, that one should have been a capital. And then this one, just double checking, that one's wrong as well. So that one is incorrect. Okay, looking at this one. We have a heterozygous crossed with a homozygous recessive. That's why they have the 2 little a's. So look at this. We have big A, little a. That one checks out. Big A, little a. That one checks out. We have little a, that checks out. Little a, that checks out. Oh, perfect. That's another one that we have that's correct. And visually, just looking at this, I know this is wrong because you can't just have one with one. But let's just see if any of the Punnett squares are correct. Big A, big A, big A, big A. Good. So this row is correct. However, this one, or column, whatever you call it, this one, A plus A, no, that one's not correct anyways. Okay. So I only had 3 that were accurate on here. Okay. It says complete the following to determine the expected offset. Okay. So now to do these, to make it visually a little bit easier to see, I'm going to color all my that's also word, dominant traits purple and my recessive traits with a kind of off, I don't know, I almost said off-white, definitely an off-white pink. So if I'm combining these, actually I probably should have done this for one. Oh well, whatever. Oh gosh, now I don't like it. Ugh, hold on. Okay, I redid this one because I really just didn't like it. I'm going to do this parent in purple and this one in pink. Okay, so I don't know. My brain is, whatever. Didn't get a lot of sleep last night. So to complete these, I have a heterozygous on top, and then I have a homozygous dominant on the side. So to connect these two or kind of create the actual Punnett square, I'm going to take my big T and my big T. I'm combining these 2 boxes right here. And it doesn't matter. These are both capitals, so it really doesn't matter which one you put first. I'm just going to put the top one first. I'm going to put my big T, because I'm combining this box and that box. Okay. Now, this is a lowercase one, so I want to put it second. I'm going to combine my big T, so big T is going to go here. And then just looking at this, it's going to be big T and little t, so I'll just bring my little t down. Big T. Okay. So you have, you're going to have 50% that are homo dominant and 50% that are hetero. Okay. But all of them are going to be dominant. They all have the dominant trait. So 50% chance of the offspring have the recessive trait within them, but they're not actually seen. Okay, so that's the first Punnett square. Now hopefully you have some of these completed. If not, pause the video right now and try this one on your own. I'm just going to do my little purple letters and do my little pink. Okay. Pause the video, try to figure out, and then hopefully do with some pencil so you can just make corrections. Yeah, but I'm going to keep going. When I have lowercase letters, I'm going to start off with my E. So my first box right here, I'll try a different way. I'm just going to go ahead and fill this in. All my E's just come straight down pretty much. Maybe this will be an easier way for you to do it. So I fill in all my E's first. I know my E goes here, my E goes here, this one goes here, this one goes here. It's kind of like the distributive property in a way. I have to distribute this E to both the boxes below. I have to distribute this E to this and this. I want to think of it as alleles. I probably should be saying E's. I'm going to distribute my capital E to this one and to that one. I'm going to distribute my little e to this one and that one. So maybe it's a little bit easier for you to do it different ways and try different ways and see which one works best for you. But really, you're just distributing them to each to see what the possibilities are. So in this case, we have This one is going to be the dominant traits to be a 50% hetero, and you don't need to put hetero dominant or hetero recessive, because if it's hetero, it has to have the dominant trait, and the dominant trait will always show through. And then it's 50% recessive. I guess we'll put homo recessive, even though if it's recessive, it has to have two of the exact same traits. Okay. So big E, yeah. Scrolling over again, if you want to try this one on your own, go for it. I would definitely recommend it. I'm going to fill in my little letters again. And you don't have to do different colors. It's just going to make it a little bit easier to see on here. Okay. So pause the video, try it right now, see if you can figure this out. Next part. If you want to do distributed property, I'll try this again. Now, this was capital, so I know it's going to go first, even though I see that this one's clearly capital. Nonetheless, I'll come back to it. Drop that big R, so I distributed it to here and to here. I have my little baby R here, here. I know it's lowercase, even regardless of what's over here. If I wasn't even looking over here, if I didn't know that, I would still know my capital can go first and my lowercase is going to go second. So even if I didn't know what necessarily was over here, so like that. So now I'm going to distribute my big R. My big R, my baby R, my baby R. There we go. All right, so this one, it gives you a kind of interesting cross. You have one, you have 75% are going to have the dominant trait. Well, 25%, that 1/4, is going to be the recessive. However, looking at this, I only have, of that 75%, 25% is going to be homozygous dominant, okay, because I have that two big R's, the big R, and 50%, so I'm kind of breaking down that 75%. 50% is going to be hetero. And you don't need to put the, I almost put recessive, dominant or recessive. It's hetero, it has it nonetheless, okay? So your answers should be, hopefully you're like, okay, I got this, I'm just going to just shut up and give me the answers. Or let me just check. So I'm going to go through, pause it real quick if you want to try this one out. This is just a lowercase one. Because they put a little strike through, it just means that they're trying to show you that it's a little bit different from the original one. So go ahead and do this one. Again, because I'm just continuing with my little color trend here. And actually, whenever I do this, it turns out looking like 8, so I usually don't do that. So I know my capital S, so I'm going to distribute that. Okay, so now I have distributed, whoops, that's a really crappy error, that to that one, that. And then let's do little s, and again, I bounce all over the place, little s, big S, big S. Okay. So looking at this, you have, all of them are going to be having the dominant trait, but in this case, 50% are going to be homo dominant and 50% hetero. And again, you do not need to specify if hetero is dominant or recessive. If it's hetero, it has one of each trait. The dominant trait always shines through. Okay. Let's go to the next page. Okay. So it says in corn plants, normal height, whoopsies, oh, for crying out loud, all sorts of issues this morning. Normal height, H, is dominant over short height, baby H. Complete these 4 Punnett squares showing different crosses. Then shade all the homozygous offspring, shade red all of the homozygous dominant, meaning the 2 capital letters. So sometimes I just like to make sure I understand. That's going to be red, and shade green all the heterozygous, which is going to be H, big H, little h. So anytime it's heterozygous, is going to be green. Now, if you don't have anything, maybe just do some sort of, I don't know, it'll surprise me. Of course, I'm looking for colored pencils, which I don't know. Oh, there they are. Duh. So I'll come back and I'll do that at the end. So looking at this, I have my little corn plant. So I have 2 homozygous plants. This one's homozygous dominant. This one's homozygous recessive. Now, it does not always matter. Well, does the homozygous dominant always have to go on top? No. In this case, the very next one, it's on the side, so it really does not matter. I'm not going to do anything special with colors here. I'm just going to go ahead and distribute them. And maybe you're thinking, okay, Miss Penny, I liked it the other way better, where you just kind of added the 2 together. So this is big H, little h, big H, little h, big H, little h, big H, little h. Okay, so that is 100% their offspring will be heterozygous. I'm going to shade this green real quick, and so I'm really going to be that intense of a green here. Okay, so that one's all green. They're all heterozygous. Okay, so I'm going to cover that one up. Looking at this one, I have my H. So I have a heterozygous and a homozygous dominant. So big H, big H, big H, big H, big H, little h, big H, little h. So remember, the homozygous recessive are all going to be unshaded. So looking at this, these two are going to, I don't know why they pick Christmas colors. I don't know. Ugh, it's Christmas time. And then these are going to be red because they're homozygous. Homozygous dominant. Homozygous recessive, which are two little baby H's, stay unshaded. Okay? At any point, you want to stop and just work ahead of me and then come back and check. That's perfectly fine. We have two heterozygous crosses now. So, is that a brain fart? I'm just going to distribute this one. Big H, baby H, baby H. Distribute my big H, my big H. Oh, Miss Penny, we're distributing the baby one and the baby. So look at this. Now this, when you do two heterozygous, you get kind of more of a 25, 25, 50%, which is a little bit nicer just to see the possibilities. So heterozygous is green. So green, green. I'll put my red away. This one's red, and then this one stays unshaded because it's homozygous recessive. It's got the two little babies. All right, now I'm just going to keep chugging along. So at this point, you kind of got it or you don't. So I'm going to combine these two, H, little h. And I've been doing these long enough that I understand I don't need to think about, oh, well, this is a baby H. I just see it and I put it. So for some of you, and this whole gesture that I'm doing, it just works it helps my brain kind of process it. We don't have any homozygous. We only have two heterozygous, so these are going to be green, and that's all you shade in for that one. Okay. Looking at this. In flies, long wings, of course you can't see it, long wings are dominant over, oh, for crying out loud, sometimes I get so excited about Punnett squares, I can't control myself. In flies, long wings are dominant over short wings. So, oh gosh, sometimes they pick such crappy letters, but it is what it is. Long wings, so W is dominant, and it also equals long. Okay. I sometimes will write out information. I'm a visual learner. I'm also an audio learner, which is why I talk to myself so much. Not just when I make these videos. And little short wings, wee little baby short wings. These are the recessive trait, and they're also short. Examine these four Punnett squares showing different crosses, then shaded red. Oh gosh, losing my mind this morning. All the offspring will have long wings. So red will be long. So it doesn't matter if they're homozygous or heterozygous. If they have that W trait, the capital W, it's going to be a red square. So go ahead if you want to pause the video and do this real quick and then check over your answers. That's perfectly fine. I'm going to go ahead and do this. This is W, baby W, big W, baby, big W, baby. And what did it say? So if it has long wings, right, it's going to be red. All of these are red because they all have long wings, all right? Maybe I should do this in a different color. I'm thinking it's probably a pretty good decision. This is big W, little w, big W, little w, big W, little w, big W, little w. Okay. So they are all going to, gosh, they look like, yeah, Miss Penny, you're losing your mind today. Yes. All right, second one. Whoops, where's my pen? W, two big W's, big W, baby W, big W, baby W, baby W, baby W. So these will all have the, oh my gosh, so much better to see. These will all have the long wings, so they all have at least one of the big W's. Now these are little baby ones. That's kind of hard to see, so I guess I'll draw a little line through them. Oops. Okay. Next one. Oh, they're all little babies. Well, gee, none of these are going to be, this one should be the easiest Punnett square. Wee little babies. Now, this could be some sort of weird evolutionary factor where all of their little offspring, two homozygous recessive little flies get together. Like, man, we both have short wings. We should be friends. More than friends. But they're all going to have all their babies. There's no chance that their babies are going to have any sort of long wings, so they're probably going to be eaten first. Oh, that sucks. But who knows? Their parents survived. This is big W, little w, little w, little w, big W, little w, little w, little w. So I'm just going to draw some little lines through these. Because these two are both homozygous recessive, these are the only two that are going to have long wings. So looking at that. Okay, I'm just going through this because, yeah, I don't think I have to color in any of these, so I'll go back to my purple pen. And guinea pigs, short hair. So in this case, short hair, the big S is going to be dominant, which is short. Okay. Over long hair, so little baby S. And if I put a line through it, it's just going to look either like a dollar sign or a number 8. So this is the recessive, and this is going to be long. So in this case, guinea pigs are supposed to have short hair. And then fill in the blanks, yada, yada, yada. So one guinea pig, big S, little s, and one is SS, so one's little baby. So one is a heterozygous and one is a homozygous recessive. So it doesn't matter which parent you put. So I'm going to separate them out. Big S can go here, little s here. Then I'm going to have my other parent. This parent's going to go here. This parent is going to go along that side. It doesn't matter which one's which. That's a little s. That's a little s. Okay. So now you're just going to fill them in. So if you want to pause the video, pause it. Go ahead and check. But I'm going to go ahead and do this. Big S, little s, little s, little s, big S, little s, little s. Okay. Expected number. So these two are going to be my carrier of the dominant trait. So 2 and 2. Okay. These two right here, I'll choose a different color. These two, get a highlighter, 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 highlighter. And those two, those are my differences. This is going to be the dominant trait, which in this case is short hair. And this one is the recessive trait, which is long. Okay, so 2 are going to have long and 2 short. So both guinea pigs are hybrids for short hair. Now this one, hybrids, means they're going to have one of each trait. Okay, so in this case, it's going to be a big S, little s. So hybrids just pretty much means it's not a purebred. A purebred would be 2 big S's or 2 little s's. So hybrids is just another word for heterozygous. So I'm just going to put that underneath here. Okay? So I have a big S, little s times, and that's just across big S, little s. Okay? So again, it doesn't matter which parent you put on the top or the side, really doesn't matter. So looking at this, here are my parents. So I'm going to have a big S, big S, big S, little s, big S, little s. I think I said something else. And 2 baby S's. Wee little baby S's. So looking at this, this one is a dominant trait. I'm just going to put a little D here. This has the dominant trait. This one has the dominant trait. That one has the recessive. Because that one does not have it. Which means that 3, because remember, short is the dominant trait, have short hair, and uno has long. Ta-da! You're now kind of good at Punnett squares. We're going to be doing practice all week, so look up for Friday because I'm not going to be here. Neither will you. Woohoo!